Hello everyone, this is Rohan Meshram, and today we are going to start a new topic in my playlist called as Concept in Phylogeny. And today we will be dealing with the clustering algorithms. So before we jump into this clustering algorithm, let me just briefly introduce you the concept of clustering algorithm, and let us also revise what we have done in our previous lecture. So before I go there, just let me check it out if we are still recording. Yes, we are still recording. Okay, sorry for this. Okay, so what we have learned till now is that these clustering methods are tree building methods that were originally developed to construct taxonomic phenograms. So this is what these clustering algorithms were first proposed for. They were proposed for generating something called as phenograms. And these phenograms and this technique for generating these phenograms was first published by Sokol and Michener in their classic paper that was published in 1958, and later on some modifications were also published by Smith and Sokol in the paper that was published in 1973. You can read those papers. So these phenograms are trees based on overall phenotypic similarity. So what are these phenograms? These represent trees that are based on an overall phenotypic similarity. And later on, these methods were applied to phylogenetics in order to reconstruct something called as ultrametric tree. Right. So this clustering algorithm was then later on reused to generate altametric trees that we are going to study in more detail. So in order to generate this ultrametric tree, the property of ultrametricity must be satisfied, right? So this ultrametricity is said to be satisfied for, well, say any three taxa. Let us consider them as A, B, and C. We say that the ultrametricity for the three taxa A, B, C is satisfied when they follow the distance equation, like if the distance between A and C is less than or equal to the maximum distance of distance between A, B and distance between B, C. So if these three taxa follow this mathematical equation, we say that ultrametricity criteria is satisfied. So in practice, this particular equation is satisfied when two of the three distances under consideration are equal and as large or even larger as the third one. So these ultrametric trees are always rooted. So this is one of the very most important character that we have discussed in our last lecture, that ultrametric trees are always rooted trees in which all the end nodes are equidistant from the root. Well, say for example, if you have got any tree, and if it is an ultrametric tree, then all the OTUs or all the leaves in this tree are supposed to be all present equidistance from the root of the tree. This is what is present in any ultrametric tree. So now this behavior can only happen if we assume molecular clock. This behavior of ultrametricity, that is the distance of equidistance of all the leaves that are present in tree to be present equidistant from the root, this property can only be followed if we assume that molecular clock exists, right? So then there are clustering methods such as UPGMA, what we term it as unweighted pair group method with arithmetic means, and another clustering method what we have is WPGMA that correspond to weighted pair group method with arithmetic means. So both of these method uses something called as sequential clustering algorithm. So UPGMA as well as WPGMA, they use something called as sequential clustering algorithm. So this is what we have discussed so far in in our previous discussion. If you somehow have ended up on this video, you can view the previous video and get into the more details of what I have discussed just now. So before now let us start out discussing how clustering algorithm works. For that, let us first define a general framework for any sequential clustering algorithm. So well, now in general, when one uses clustering algorithms for tree reconstruction, the tree is usually built in a stepwise manner. That is, more than one step would be involved in generation of the final phylogenetic tree. So for using such sequential clustering algorithm, we essentially need this distance matrix as an input. So every sequential clustering algorithm begins with a distance matrix. So what happens is that we keep on grouping sequences or group of sequences as per the values that are present in this distance matrix. So the sequences that are present in this distance matrix are called as OTUs. We would call them as operational taxonomic unit. So now the said grouping is done on the basis of the genetic distance that is noted in this distance matrix. So thus sequences with small genetic distance in this distance matrix are considered as similar, and the sequences that share larger genetic distance are considered as dissimilar. Therefore, in any sequential clustering algorithm, we start grouping the sequence or group of sequences that are most similar to each other. So in other words, we group the sequence that are having the smallest genetic distance, and hence we call such a group as clusters. So such groups are called as cluster, and hence we have the name of the technique called as clustering algorithm. So what we do is that we perform this clustering iteratively, and thus the tree generation procedure might have multiple iteration before we end up in this final phylogenetic or evolutionary tree. Well, now at each and every iteration, the distance matrix would be updated. For first iteration, we have this distance matrix. Then for second iteration, the matrix might have been updated. Why? Because we might have grouped one or two of these sequences as such, right? So my point is, at each iteration, the distance matrix is updated as per the grouping that is done in the previous step, or the grouping that is done in previous iteration. And the newly generated matrix that we end up with is used for then subsequent iterations. So for example, when two OTUs are grouped together in this first iteration, we'll say for example, now if we decide that we are going to group this A and B, so if these two groups are if these two OTUs are grouped together, then in second iteration, this AB group will be considered as a single OTU, right? Uh, then in second iteration, this AB would be considered as single OTU, and from this new OTU, the next pair with the highest similarity will be identified. So we would continue this iteration procedure till only say two groups are remaining, right? So to keep tab of the number of OTUs at each step, we would say define a variable called as n. So this n would account for the number of OTUs that are under consideration for each calculation. Well, say for example, at this stage, we have 6 OTUs present in our analysis. Therefore, the n would be 6. Then in the first iteration, we decided to have to group these two OTUs A and B. Therefore, we have group this A and B together. It will form a cluster, and hence now we will have how many sequences are available there now. We have this one OTU, second OTU, third OTU, fourth OTU, and fifth OTU. So here n is equal to 5. Then maybe we in the next iteration, based on whatever distance matrix that we get over here, now, say for example, we have decided to group these C into already group A and B. So here again, the number of OTUs for the subsequent distance matrix generation would be 1, 2, 3, and 4. Therefore, n would be 4 over here. And in this way, at each step, we would generate a new distance matrix. After generating that new distance matrix, we would cluster the sequence and eventually decrease the number of n by 1. And then we would move on to next generation. We would continue doing this till we get only two OTUs that are present, and this would be the final step of your clustering algorithm. So when the two OTUs will remain in your computation, the next step would eventually give you the final phylogenetic tree. So this is how we usually go around when we deal with sequential clustering algorithm. So in short, we begin with the number of sequences, we compute the distance matrix, we compute the distance between the two sequences, then we cluster the two OTUs that are having the smallest distance, and eventually we would then decrease the number of OTUs by 5, and we continue doing this thing till we get, or till we are left with only two operational taxonomic unit, and after this you would get the final tree. So this is in very brief a general framework of clustering algorithm. How is that sequential clustering algorithm will work? Well, now let us start out solving one of such clustering algorithm using using WPGMA method, and let us see how we can build a phylogenetic tree if we start out with a simple distance matrix, or the matrix that contains the genetic distance between the given sequences, right? So to begin with, let us use the same matrix that we have considered, right? So our matrix contain sequences like A, B, C, D, E, right? These are the 4 sequences. And on the other side, we would start our numbering with like B, C, D, E, and F. Now note that I have not included A in the column. By not including A, I have I have kind of I have removed the possibility of self comparison of, or you can say that by not including A over here, only the only the sequences or OTUs that differ would be occupied in our distance matrix. So there would be no self comparison. So there would be no value in the diagonal matrix that usually forms when we might have tried it using any dynamic programming algorithm. So you can also begin with this way, right? So say for example, we might have genetic distance like 2 that correspond the genetic distance between A and B. Then say for example, if we have genetic distance of 4 and 4 that correspond to the genetic distance between A and C and B and C. Let us assume that we have genetic distance of 6, 6 and 6. Then for F, for E, let us have genetic distance of 6, 6, 6 and 4. This 4 would correspond to the genetic distance between D and E. And we'll say for example, we have genetic distance like 8, 8, 8, 8 and 8. This 8 correspond to the genetic distance between E and F. So, well, say for example, let us begin with this simple distance matrix with the genetic distance that we have calculated. This might have been calculated with say any evolutionary model, but well, say this is a hypothetical uh, distance matrix. So I have kind of included these numbers just to make the calculation simpler. Usually, the genetic distances that are calculated are present in decimal places with a very complicated number. So since we are going to just demonstrate of how algorithm work, let us keep the numbers simple, right? So the very first thing that you need to do is that when you begin with such genetic distances, or you can say when you begin with a distance matrix that has such genetic distances, to begin with any sequential algorithm, you need to find the pair of OTUs with smallest distance in such distance matrix. So the smallest distance correspond to this value of 2 that correspond to the genetic distance between sequence A and B. So it's 2 in this case. So this 2 corresponds to the distance between OTU A and B. So once we have identified such a value which correspond to the minimal genetic distance between the corresponding OTUs, the next step that is involved is to calculate the depth of divergence. So we would call it as depth of divergence, DOD, later on in this discussion. So how is that we calculate this depth of divergence? So this depth of divergence is simply the average of the distance between A and B. So that is, the depth of divergence would be the distance between A and B divided by 2, right? So this is what we have done. Based on these two, we have now cluster A and B, and after clustering, we have calculated this depth of divergence, which correspond to the distance between A and B divided by 2. So what is the distance between A and B? It is 2. 2 divided by 2, that will give you 1. Therefore, we will give the weight of 1 over here. So in this way, by calculating the depth of divergence between the observed OTU, you will always end up placing the OTUs equidistant from the root, and this is exactly where, my friends, the ultrametricity is implemented in such sequential clustering algorithm. Okay, one more thing. Over here we have got 6 OTU, therefore n in our case would be 6. We have begin with 6 OTUs, therefore n would be 6. And based on the numbers that are present in our distance matrix, now we have decided that we would pair A and B together. And after pairing A and B together, we have calculated this depth of divergence by simply taking the average 2 by 2, that will give to 1 and the value of 1 and 1. So well, now let us move on to the next iteration, right? So for the next iteration, we need to compute the distance of OTUs from newly formed node A and B. So let me generate the distance matrix for the next iteration. So in our previous iteration, we have decided to group A and B together. Therefore, what we will have is that we will have A and B in a single OTU now. Then we have got C, then we have got D, and then we have got E, right? Now, since we have clustered this B with A, therefore in our column, we will no longer have this B, and our column will begin with C, D, E, and F, right? So this will be our new distance matrix for our next iteration, or what we can say the next iteration, or the next step of calculation. So since we have clubbed A and B together, therefore we would have to now calculate the distance between this newly formed OTU with all the remaining OTUs that are present in our calculation. That is, we need to find out distance between AB and C, distance between AB and D, distance between AB and E, and distance between AB and F, right? So what we have to do is that we need to compute the distance of other OTUs from the newly formed node AB. So we can use the data from the previous distance matrix here, right? So let us calculate the new distances column wise, and this is where your WPGMA algorithm would be implemented. So now how is that we calculate the distance between AB and C? So we have a simple formula for this thing. For calculating the distance of AB from C, what we do is that we calculate the distance of AC, add it with distance of BC, and then divide it by 2, right? So now what is the distance between A and C? That is, we have got 4. What is the distance between B and C? Again we have got 4. 4 plus 4 divided by 2, that will give you the value of 4. And now this 4 would be populated over here. So similarly, we would go on calculating what is the distance between AB and D. Distance between AB and D. So similarly, how is that we are going to calculate it? It is going to be distance between A and D plus distance between B and D divided by 2. That is, what is distance between A and D now? A and D, we have got 6. Distance between B and D, again we have got 6. 6 plus 6 divided by 2, that will give you the value of 6. So 6 will be populated over here. Similarly, now we have to calculate distance between AB and E. Distance between AB and E, that would be given with the distance between A and E plus distance between B and E divided by 2. That is 6 plus 6 divided by 2. That will get 6. Let us populate over here with 6, right? And finally, we need to figure out what is the distance between AB and F. Distance between AB and F would be, distance between AB and F would be addition of distance between AF plus distance between BF, and we would have also have to divide it by 2. We would end up adding 8 plus 8 divided by 2, that is 8. Here is how we do it, right? So in this way we have populated the column that correspond to the distance between AB and C, AB and D, AB and E, and AB and F. Okay. So since there is no change in the remaining column, therefore we can take the values from the previous matrix, right? So there is no change, or there is no calculation when we have we didn't do anything with C and D, right? So we can use the values from our previous matrix as it is in this case. Here we, in case of D, you can have 4, and you can have 8, and finally you can have 8. So these values are taken as it is from the previous distance matrix. Why? Because the grouping has not been done in these cases, right? So in this way you update your distance matrix for the next pairing, right? So over here now, how many OTUs do we have? We have 1, 2, 3, 4, and 5. Therefore we would decrease the number by 1, and the n in this case would be 5, right? So in this newly formed matrix, now find out which one is the lowest number and start out with it. So in this case you can see that we have 4 over here, right? This 4 correspond to pairing of D and E. Well, let us focus on this 4. Alternatively, there is another 4 present over here that would correspond clustering of AB with C, right? This can also be done, but let us first focus on these 4 that correspond to clustering of D and E. Remember that we have already clustered A and B together, right? So as per the procedure, after identifying pair with the smallest distance, we proceed for calculating the depth of divergence, right? So here depth of divergence between the sequence D and E will be 2. That is, we would take an average of what is the depth of divergence between D and E. That would be 4 by 2, and therefore the depth of divergence in this case, in case of D and E, would be 2, and hence we would end up pairing D and E, and the distance would be 2 and 2 in this case. So what is that we have done? Now we from starting with the initial pair, initial set of sequences, we have now paired A and B, and now we have decided to pair B and E together, right? And after doing so, we have decreased the number of OTUs with 1, right? Now the in the next step we would have n is equal to 5. So after doing this, now let us create a new distance matrix by grouping or clustering D and E. For that we will have to calculate distance of DE from each node that is remaining, right? So this is what will happen now, right? So in the previous matrix we have already paired AB, right? We have already paired this AB, so it will be carried forward as it is, right? So first column will be AB. We are leaving C out of this calculation, right? And the third column would be DE, right? Because we have decided to group D and E together. So in this case, in the case of row, it would be the same. The first row will be C, right? And the right together DE. Therefore, the second row would be DE, and the one that would be left is F. So this is how our new distance matrix might look like. We have already paired A and B, therefore it will be carried forward as it is. Then we have considered these 4 and not these 4, right? Therefore C would be left behind, and now we have decided to pair D and E together. So we have got this DE, right? In the case of rows, C would be left as it is. We have now paired this D and E together, therefore it will form another ODU called DE, and F is still remaining. So this is our new distance matrix. A and B paired together, D and E paired together, and D and E paired together. Right. So how many OTUs do we have now? Over here we have like 1, 2, 3, and 4. Therefore N would be 4 in this case. Right. So next thing that we need to do is that now we need to figure out what is the distance of this DE from C and DE from F, right? So that is what we have to do now. So now let us compute the distance of remaining OTUs. We already know that the distance between AB and C from the previous matrix, right? We would just fill up the column, fill up column wise, right? So we already know what is the distance between AB and C. We have distance of AB and C is 4, right? Let us carry forward as it is. So next in column is distance between AB and DE. That is this is very interesting, right? So now first we need to do is that we need to calculate what is the distance between DE from AB, right? So what would be the distance between this DE and AB, and how is that we are going to calculate? The formula would be like distance of D from AB plus distance of E from AB. That is what we are going to do. In order to calculate the distance between D and E, what we would do is that we would calculate what is the distance of D from AB. We would add it with what is the distance of E from AB, and of course we would divide it by 2, right? That is what we are going to do is that we would calculate the distance between D and AB, add it with the distance between E and AB, and then divide it by 2. So what is that we get? We would get 6. What is distance between D and AB? AB and D, that is 6. What is distance between E and AB? E and AB is again 6, right? So 6 plus 6 divided by 2, we would end up with 6, right? So we have 6 over here, right? Next in the column is the distance between AB and F, that we already know it is 8, right? AB and F, right? So we can also calculate this using our formula. Distance between F and AB would be distance between F and A plus distance between F and B, and we would divide it by 2, right? What is distance between F and A? That is 8 plus 8 divided by 2, that is 8. That is simply we have put it over here. Next we have distance between DE and C, this column. What is the distance between this DE and C? So how is that we calculate distance between DE and C? We calculate it using formula distance between DC plus distance between EC, and then divide it by 2. What is that we have? Distance between D and C is again 6. distance between E and C is again 6. You can check out the previous matrix, and we would divide it by 2. That will give you the value of 6, right? So therefore we would populate 6 over here. Right. Next we have the distance between C and F. That we already know, distance between C and F is 8. We would carry it on 8, right? Let's carry forward it. So next we have distance between D, E and F, this column, right? So how is that we calculate the distance between D, E and F? Distance between D, E and F would be given as the sum of distance between DF plus distance between EF divided by 2. That is 8 plus 8 divided by 2. We would end up with 8. Right. So DE and F, we have got 8 over here. So this is the new distance matrix, right? So in first iteration, we end up with clustering A and B together like this. In second iteration, we end up with clustering D and E together like this, and hence we have this distance matrix that is updated that can be used for next iteration, right? So what we have already decreased the total number by 4. So now the new n is 4, right? So in the new matrix so form, let us group together the OTUs for which the distance is minimal. So now see what is the OTU that correspond to the minimal distance. We have got 4, and this 4 correspond grouping of already grouped AB with that of C. Already grouped AB now can be paired with C. Therefore, based on this, how the new tree might look like, we have already grouped A and B together, and now we are trying to group C with the already paired A and B. So the depth of divergence would be, we would calculate the depth of divergence, 4 divided by 2, right? Where should I write? Depth of divergence is 4 would be 4, taking the average of distance between A, B and C would be 2. Therefore here we have got 2, and of course we have got 1 plus 1 2. Therefore all of the nodes are present at the equidistance, right? So this is how things work. So in this way, we decide to group C in AB to yield the new node A, B and C. Now let us compute the distance of the newly created node A, B and C with the remaining nodes, right? Or cluster the, or you can say we would have to create a new distance matrix for this thing, right? So let me create a new distance matrix. So new distance matrix might look like what we have done now. We have decided to club this AB with C. So what we will have is AB and C together, right? And of course we have remaining DE, right? So now since we have moved this C to this ABC, so in case of rows, we will have DE and F. So this is how your new distance matrix might look like. So in short, what we have done is that we have paired AB first, right? Then we have paired this D and E together, right? We have given the value of 1 and 1. Third step, we have then clustered C with that of A and B. We have given the value of 2. यहाँ पर भी you have got value of 2 and 2. So this is what we have done, and F is still remaining. So this is how we have been doing with our clustering, sequential clustering algorithm. So far so good, right? So now let us try to fill up this new matrix, and then we would decide which is the pair that is needed to be grouped together, right? So let us now calculate what is the distance between this ABC and DE. Now this would be quite really interesting to do so, right? So now what we need to do is that we need to figure out as to how is that we calculate the distance between this ABC and DE, right? So how is that we calculate the distance between ABC and DE? Well, I would need a bigger space over here. So what we need to do now is that we need to calculate what is the distance between ABC from DE. So here is how the trick is. For doing that, what we would do is that we would calculate the distance between AB and DE, and we would calculate the distance between C and DE. That is how things happen, right? We would calculate what is the distance between this AB from this node DE. That is, we are trying to calculate what is the distance between these two nodes and what is the distance between these two nodes. That is what we are conceptually trying to do, right? Let me note it down so that things will get more clear. For doing this, we would be first calculating what is the distance between AB and distance between DE, right? Let us assume it as x. Then we would add distance between C and DE, right? Distance between this cluster AB from cluster DE, that is, we are calculating distance between these two nodes, right? And then we would be calculate what is the distance between DE with that of C, that is this node, right? Let us assume this as y. So what is the distance between AB and DE? How is that we can get? The distance between AB and DE is 6. Therefore, we will write 6 over here. And what is the distance between C and DE? C and DE, it is still 6. C and DE, 6 plus 6 divided by 2, right? That is equal to 6. We would get it 6 over here. Therefore, 6 would be given over here. Okay. Now, next in line is what is the distance between this ABC and F. We would to fill up these positions as well. So how is that we would calculate distance between ABC and F is distance between AB and F plus distance between C and F. That is what we are doing, right? Distance between ABC and F. How is that we do? We would calculate what is the distance between AB and F, and then what is the distance between C and F, right? So what is the distance between AB and F? Distance between AB and F is 8. We would have 8 over here. Distance between AB, so distance between C and F. C and F is still 8. 8 plus 8 divided by 2, 8. So we would put 8 over here, right? Okay. Now we already have calculated distance between DE and F, right? So DE and F, the distance is 8. DE and F, the distance is 8. Therefore, we can carry forward it. So this is our new matrix now. So now as per the new matrix, which is the smallest distance? Of course, this 6 that correspond to the uh, to the grouping of AB with that of DE. And therefore, how many OTUs that we have now? 1, 2, and 3, right? So we have decreased the number by 1. Therefore, N would be 3. So this is what conceptually we are doing. So what we are doing is that we have paired A and B together. The depth of divergence was 1 and 1. Then we have paired D and E together. The depth of divergence was 2 and 2. Then we added C, giving the depth of divergence of 2. And now we are going to add this DE to the already group ABC. Right? So this is what is happening over here. So now this is how so far we have generated our phylogenetic tree, right? So at this stage we have clustered A, B, C, D, and ABC, the OTU ABC, DE, and still F is remaining, right? So for the next subsequent matrix, what we have got is we have got this A, B, C, D, and E on one side, and we have got F on the other side. So in this way, we have got only N is equal to 2, right? So since we have reached this condition, this would be our final uh, this would be our final step in the clustering algorithm. All we need to do is to fill up this box and the tree would be generated, right? So now we need to fill this one remaining box and our job would be done. So what we need to do is that we need to figure out what is the distance between A, B, C, D, E from that of F. And how is that we do it? We do it by calculating distance between ABC and F to the distance between DE and F, right? And then we would divide it by 2. So now what is the distance between ABC and F? That is 8. What is the distance between DE and F? ABC and F, we have got 8. DE and F, again we have got 8. We would divide it by 2. 8 plus 8 divided by 2, that will give you 8. Therefore, finally, we would have got 8 over here. Right. So, next we would calculate depth of divergence would be 8 divided by 2, that will give you 4. So, eventually, what we have done is that at this step, we have begun with like A and B, the depth of divergence was 1 and 1. Then D and E, the depth of divergence was 2 and 2. Then we have added C with the depth of divergence 2, right? Then we have added ABC to DE, right? We have added ABC to DE, and eventually we have got this F with the depth of divergence of 4, 3. Okay. So here, my friends, you end up with the phylogenetic tree using a sequential algorithm called as WPGMA. So this is how you know WPGMA would work, right? So now let us build up a generalized expression for WPGMA algorithm. So whatever we have been discussing so far in this WPGMA method, the averaging of the distance is not based on the total number of OTUs in the respective cluster. That is what we have learned. So by that, what I mean, say for example, when we begin with A and B that were already grouped, and we have got C, right? When the OTUs A and B, which have been grouped before, and C have been grouped into a new node, well, let us call this node as U. Let us call it as U. So this is the situation that we have. And then the distance of this node U from, we have got another node D and E. So consider it as E, right? And let us consider it as node K, say for example. Okay. Now we are giving names to this node, small u and small k. So what we are doing is that we usually calculate what is the distance between these two nodes u and k, right? So this distance between u and k is given by simply distance between a and b into k plus distance between c and k divided by 2. So in this way, you go on adding nodes to each other, and this, my friend, can be termed as a very general formula for WPGMA algorithm, right? So this is what we have done, right? Do you remember we have calculated the distance of AB from K, then we have calculated distance of C from that K. K correspond to already paired D and E. So if you go on doing such a thing, you say that you are following this UPGMA algorithm. And in this way, now you might get an idea that the averaging of the distance is not based on the total number of OTUs in the cluster. It is based on the nodes itself, right? So this, my friend, is the general expression for WPGMA algorithm. And maybe in our next video, we would try to look into more details of WPGMA algorithm and try to derive its general expression as well. So this is what I have for you today, my friends. So see you in our next video.